Hi, everyone. Please take your seats. We're going to be starting now. So thank you for coming to Getting Started with Debugging on Linux. So please welcome Bruce Dawson from Valve.
Good afternoon, everyone, and thank you for coming to Steam Dev Days. My name is Bruce Dawson, and I'm a Linux developer. Woohoo! That's actually a really weird sentence for me to be saying. I've been developing on Windows for, as far as I can tell, 20 years. I worked at Microsoft for 8 years. I worked on Windows for a little while. And I am a Linux developer. I'm not an expert. I'm not like Ryan Gordon and Sam Landinga, who are the uber nerds of Linux development. But I can get work done. I can be productive on Linux. Now, it was not always a painful or a pain-free process moving from Windows to Linux. There was definitely some false steps in there and some discovery that was needed. But I think having gone through that process, I can save you from making some of those false steps. And my goal, my claim, is that in less than an hour, I can get you to be productive developing on Linux. We've already used 5 minutes, so we better get going. So there are definitely a few challenges. First of all, finding my PowerPoint clicker. Well, we don't need that. OK. The default debugger on Linux is, I would call it user hostile. There's different opinions. It's certainly intimidating to new users. Very powerful, but intimidating. Little things like getting symbols in source code to show up when you're debugging. Well, that takes some work. There's different techniques for doing it, and they're not obvious at first. And if you've been developing on Windows for years, you've developed a library of tricks, and you know the tools that you need to use to solve the many problems that developers have to deal with. And you have to start over on Linux. Well, in the next, you can be productive in Linux quickly. That's what we're going to do. And in the next hour, we're going to solve all those problems completely, 100%. OK, moving right along. This is the default debugger for Linux. GDB, the GNU debugger. It's extremely powerful. This is an industrial strength debugger, but it's got two significant problems for the way that I like to get work done. First of all, you launch a program that you want to debug, it comes up, and it's just a blinking cursor. If you don't know the right command, you can't even launch your program. Once you hit a crash, if you want to get a call stack, if you want to walk up the call stack, if you want to display local variables, it's a lot of web searching to find out what the commands are. So you're not going to be at your most productive. Once you learn it, it can be an amazingly powerful tool. And when something crashes in a data center on the other side of the Atlantic Ocean, and you can connect to that machine using this tool, well, that's really awesome. So somebody in your studio should know this, should know how to use this tool. But it doesn't have to be you. The other problem I have with this debugger, and this is not something that everybody agrees with me on, but I like my debugger to show me huge amounts of information about the state of my program. When I single step, I want to see the call stack update, the locals window update, the registers window, the disassembly, the source code, and probably a few other windows that I've forgotten about. You can get all that information in GDB, but you have to type in a command for each piece of it. And by the way, it is showing us a little bit of rich state. GDB is currently showing us the line of code that we're executing on, but it's easy to miss because it's just a single open paren. That's not really enough context to figure out where in my million-line program I am. CGDB is the next step up. And this is very easy to install. It still works remotely over SSH. And it does show you that most important piece of context, the source code that is currently executing and the neighboring lines. So this is definitely progress. This is my preferred tool when I can't use one of the heavier weight GUI tools, just because of the source code display. But it still has the problem of needing to learn all those commands in order to get anything done. A couple of other options are WinGDB and Visual GDB. These are Visual Studio extensions. If you've done development on an Xbox 360 or, well, I don't know what PlayStation 3 development is like, but probably similar, you're familiar with this concept. It's remote debugging, remote building. You're running the compiler on your Linux machine, but it feels like you're running it on your Windows machine. These are perfectly valid options. They're commercial tools, so you'll have to buy them. And it means you're not really committing to Linux, so you're missing out on some of the advantages of being on Linux, and you'll just have to decide whether that's a good or a bad thing. But anyway, I'm not going to talk about these two tools. I'm going to talk about a different debugger option, which I think you should consider. Oh, by the way, here's a couple of screenshots from those two tools, just showing them integrated into apparently a very old version of Visual Studio. This is the tool that I think you should take a look at least. It's called Qt Creator. Ryan mentioned this earlier in his talk. And this screenshot looks terribly busy, but that's not the fault of Qt Creator. That's just me trying to show you how much information it can show you at once. And then I squeeze that into a slide. On a big monitor, this looks glorious instead of cramped. Now, I could spend a few minutes just talking about all the information that's being displayed here, but rather than do that, rather than talking about debugging, let's do some actual debugging. Let me sit down here for a minute, and we'll see how much stuff we can explore in just the few minutes we have allowed. So this is a, man, just sizing Windows and Linux is painful sometimes. Really, if this is the hardest problem you ever have to deal with, then you're okay. All right, so here we are in the terminal on my Ubuntu virtual machine running on my Windows 7 machine. Not the ideal scenario for debugging, but really pretty cool for doing demos. So I'm sitting inside this directory with a dev days name, and what do you know, there's some source code in there, and there's a make file. So we can start doing this old school by typing make, and we've just compiled the code. And let me increase the font size a little bit so you can see it. Compiled a couple of source files. There was a warning, and dealing with that from the command line is a pain. You have to go track down that source file and manually go to the right line, and then you've forgotten what the warning was. So we're going to ignore it for now, and we'll deal with it when we've got more civilized tools. Then it links it, and we can see that the name of the executable is civ. So let's try running that and see what happens. We have to go // because in the world of Linux, if you want to run something in the current directory, you have to be explicit about it. Security. Hello world, prepare to civ numbers, core dumped. Okay, so this was not a very successful run. We could try running this under CGDB, and sometimes this will be what you want to do. And I will tell you a secret, if you type R, that will run your program. So it crashed somewhere in what is basically the C runtime library. Now, in order to find out where we were calling this from, we need to get a backtrace, we need to display variables. There's a lot more stuff we need to do. And I don't want to go down this path. There are some people who like GDB and like CGDB, and I'm not going to try and change those people's minds. If you like your debugger, you can keep your debugger. But I think there are better plans for at least most of us. So Qt Creator. It only takes about a minute to install, but I didn't want to do that as part of the demo, so it is already installed on this machine. And in order to run it, I just have to press the Windows key, which, not unlike Windows 7, brings up a little search area, and I can just start typing, and there it is. Pretty easy so far. We can also dock this to the taskbar. We can move it around, put it where we want, launch it by typing Windows 3. Using the Windows key to launch things in Ubuntu just feels weird, but it works really well. And now we need to create a new project. We're actually going to just hook up to those existing files. And because it's a makefile project, I know I need to actually go to import project and import existing project. Qt Creator also has support for CMake and CMake and various other ways of creating tools. And while the name does suggest that it's primarily for creating Qt applications, and indeed it's got a lot of extra support for that, it is a full-fledged, powerful C++ debugger. It's industrial strength at this side job. So we'll call the project civ, we'll browse, go up one directory, there's our directory. There's our list of files that it's going to add. It just scanned the entire directory recursively and added all those files to the project. We can manipulate the list of files later if we want to. Okay, so we now have a project that wraps our makefile. The project was already built, so we don't need to worry about that. We just need to run it under the debugger. Is there anybody, or let me be specific, are there any Visual Studio developers in the audience who would like to guess what keyboard shortcut we're going to use to launch this under the debugger? F5. I don't know, but let's give it a try. The one minor glitch is it still doesn't know what our program is called, so it doesn't actually know what to launch, but we know, so we'll just type in civ. It's still crashing, but that's actually good because any bug that we can reproduce, we can fix. So we're seeing the source code, and by the way, this is actually really important. We're seeing the source code to the C runtime library. It found the source, which means it also found the symbols. I'm basically foreshadowing, because I'll tell you how to make that work later on. But you should right now just be pleased for small miracles. We can hover over S, and it tells us the variable. If we're going to be displaying local variables, I think that's a very civilized way to do it. We've also got a local variables window, and you'll notice it's saying that a lot of the variables are optimized out. That's because GCC and GDB working together actually keep track of what variables still exist and what variables don't and where they're moving. So unlike Visual Studio, which usually lies to you in optimized builds, GCC and GDB usually tell you the truth. So weird concept, takes a while to get used to, but this is one of those areas where potentially it's better on Linux. That's not entirely true because Microsoft fixed this recently, and if you apply the right undocumented command line switch, you can get this behavior. But anyway, GCC, GDB have had this for a long time. So we can see our local variables. We have a call stack down here. I'm just going to right-click and adjust the column widths so we can see everything. Start walking up the call stack. And hey, there's our code. We can hover over the variable and see that argv only has one item in it, and we're dereferencing the second one. Pretty simple little bug. I'm going to fix that by having a default value, and then if argc is greater than 1, then and only then will I dereference argv element number 1. Okay, so we've probably now fixed the bug. We can hit F5 to launch it again. Well, we haven't stopped debugging, so let's do that with Shift F5. It now tells us you're going to have to save the files. I'm going to tell it to stop nagging me about that and just automatically do it. It automatically runs the build and then launches the program, and then it ran to completion. Put the application output here, and there's a whole bunch of prime numbers. The application output can be viewed here, and you can also use, because they have great support for keyboard shortcuts, Alt-3 to toggle that, Alt-4 to toggle the compiler output. So some pretty good keyboard shortcuts and kind of Windows-compatible style shortcuts as well, which can help make you really productive. Now, running your program until it crashes is one form of debugging, but occasionally you want to debug a program that is not doing anything so obvious as just crashing exactly where the bug is, and you want to step through it. And we've got lots of ways to do that. Go to the line of code you want to stop on and press F9. Click in the gutter. Go to the breakpoints window, right-click, and say, I want to add a breakpoint. And you can add it by function name, by line number, from when an address is modified, where memory location is modified, all sorts of different options. You can also, and this is in some perverse way my favorite way, use F10 or F11 and just step into main. So that's really cloning the Visual Studio semantics of how F10 and 11 should work, the fact that they can be used to start debugging. And again, it just makes it easier to do the transition and get you productive. So we can step along F10, F10, F11 to go in. And here we have a vector of bools, and in the locals window we can expand that and notice that Qt Creator knows how to display a standard vector. It's a little thing, and yet it's kind of nice. And there we can see it being filled in. By the way, can you read the code? I can make it larger. I haven't figured out how to make the text in the local variable window larger, so if you can't read that, you're out of luck. But there's nothing too important in there. Basically, there's a full set of debugging functionality, and it's all exposed graphically, so you can find it. An expression evaluator is basically a watch window entry, so you can add those to monitor some arbitrary expression, unless you're trying to, if you're trying to remember what pi times 5 is. It can do that. We got the breakpoints window, list of all the loaded modules, registers window for when you're going a little bit lower level. You can click on the disassembly window and see that. And when you do that, it will now single step by machine language instructions instead of lines of source code. To be completely honest, the disassembly window is kind of terrible, and it omits some instructions. On the other hand, Qt Creator, it's only the call instructions, and I'm assuming those aren't important, but I don't know very much. It is open source, so potentially, if you're feeling ambitious, you could go in and find the cause of the bug and fix it, or any other problems that you might encounter. We do have some developers at Valve who have experimented with that. They're building Qt Creator, running their built version, so they have the power to make fixes that they want. We've got other developers who are a bit lazier, like myself, and we just downloaded it and ran that version. So that's a pretty good overview of the debugging capabilities. But wait, there's more. It turns out that Qt Creator is actually, by the way, this is Control-Tab to go through the source files, but you can kind of predict that most of this stuff is going to be pretty familiar and compatible. Let's say I'm looking at this call to run civ, and I've forgotten what source file it's in. You want something like IntelliSense that's going to help you locate that. And follow symbol under cursor sounds kind of tempting. Let's click that. And indeed, that takes us to the definition. If we press F2, that was its keyboard shortcut, it then takes us to the declaration. And we can use Alt left and right arrow keys to go backwards and forwards through the navigation history. I'm feeling pretty happy already with those options. We can also go down here or type Control-K and just start typing the name of any source file. So main.cpp, or it's just substring matching. So KER will match worker.cpp and worker.h. If you start with a colon, then it's doing symbol matching, so I can type civ, and it matches run civ. I haven't used this for a really long time on large projects, but the other Valve developers who have say that they find that it is generally faster and more reliable than Visual Studio's IntelliSense. Did we mention it's free? So that covers the basics of how you use Qt Creator both to debug code and to write code. I'm going to switch back to my slides now and continue on. One important thing would be, well, how do you get it? If you try installing it using the package manager on your distribution of Linux, you will probably get a very old version and you will be unhappy. Qt Creator 3.0, which is what we are all running, came out in December. And you just have to go to the qtproject.org website, download the package, and don't forget to mark the run file as executable before you run it. So the download is going to look something like that. You don't need the entire Qt 5.2 binary package unless you're going to be creating Qt apps. You just need Qt Creator. That's the debugger and IDE. And that's the UI for marking a file as executable. Once you do that, you can just double-click on it in the Ubuntu Explorer or whatever they call it, and it'll run and install. So these next few slides just reiterate what I finished demoing. So I'm going to not go over them, except that one of them reminded me about another thing that I'm going to show you. You remember about 10 minutes ago when we compiled this code from the command line and there was a compile warning? That might be important. We should probably look at that. So we just need to recompile the project. We can go clean all and then build all. And indeed, you'll see that there's a little warning triangle on there in the lower right-hand corner saying that there was a build warning. And in the issues area, it's got a list of all the warnings, just the one in this case. We can double-click on it, and it takes us to the warning. They've even got a little triangle in the gutter of the source file to make sure if you're casually looking through the file, you'll see, yo, there's a problem. And the warning is that there's too many arguments for this printf. We've got 1% D format specifier, and we're passing in 2 integers. So we either need to add another format converter specifier, or we need to delete scan count. So not a big deal, but first of all, nice to have an IDE that helps you with your warnings, just like Visual Studio. But it's also worth noting that this is a warning that Visual Studio by default does not give you. Unless you're running /analyze, Visual Studio will not tell you about this bug or lots of other similar bugs. Now, we run /analyze, so we do find these bugs, but it is kind of a pain, and having that just be part of the normal compile, well, some things are going to be better on Linux. I have to admit, of course, that that project we were just looking at was a toy project. It was 2 source files and about 100 lines of code. So how do we know that this is actually going to scale up to a large project? Well, the main reason we can say that it will scale up to a large project is we are using it on large projects. So Rich Geldrich is using it to develop Vogel. Alfred Reynolds is using it to work on Steam. I'm using it to work on Team Fortress, and there's various other people using it as well. So it does work on large-scale projects, and it's efficient. But there's at least one important thing you'll need to know in order to use it effectively on your games, especially if they're launching from Steam. You see, a game is going to need more than just the C runtime. It's going to depend on a lot of shared objects. Shared objects are just the Linux version of DLLs. It's going to need them for things like audio and whatever other services that your game needs. What we do is we ship something called the Steam Runtime, which is a package of these shared objects, a commonly used set of shared objects that we think a lot of games are going to use. We ship them with Steam and launch your game in an environment that makes them available. That way your game will run, despite distro fragmentation, whether it's real or not, your game will just run on all these different variations on Linux without you doing much of anything at all. We've gone to the trouble to make sure these shared objects are available. But we need to tell the Linux loader that it's okay to load these shared objects from several different locations. And LD library path is the environment variable that you need to use for that. So in a real project, in a game, you're going to need to set this inside Qt Creator in order to be able to launch and then debug your game. Run.sh is the shell script that sets up LD library path. So we need to use it to figure out what it's setting LD library path to. And the best way to do that is have run.sh, instead of launching your game, launch the printenv command and tell it just to print LD library path. Seems a bit circular, but it works perfectly. It's a bit of an eye test. It's kind of a ridiculous number of directories. I secretly suspect that they're all printed 4 times, but I haven't proved it yet. But it doesn't matter. All you have to do is select that blob of text, and we're going to paste it into Qt Creator. You can just go to the project section. You can configure all sorts of things here, like runtime command parameters, build options, different things like that. Go to the run area, go down to the environment section, click add, type in LD library path, case matters on everything in Linux, and then paste in that big long string of text. And now you're set, now your game will launch. One other thing you can do with Qt Creator is, let's say you're on the terminal window. And I think in Linux, you're more likely to spend time in the terminal window because it's really good. Let's say you're in the terminal window and you want to load up a source file. You want it to load up into a running instance of Qt Creator. Well, if you want qtcreator.sh -client and then the name of the source file, it'll load it into that existing instance of Qt Creator. If you wrap that in an alias, then you don't have to type quite so much. And if you put this in .bashrc, that's one of the shell startup scripts, and that means the alias will always be available. All right, I'm not going to talk about the debugger anymore. And this next part of the talk is going to be of more interest to people who actually have spent time developing on Linux already. This is something that a lot of Linux experts are still not entirely confident in. So I'm hopeful that if there are any of them still in the room, that they'll get something from this part of the talk. Getting symbols or debug information, as they're more likely to call it on Linux, to show up is obviously very important. You want to know what function you're in, what your variables are, all that sort of information. And it's going to take a few steps. We're kind of spoiled on Windows. Point your symbol server at your own symbol server and at Microsoft's, and you're pretty much done, and then you forget it was ever an issue. And it is more complicated on Linux, but if you follow these steps, it will just work. The first thing is you want symbols for the C runtime, so that when you crash deep inside A to I, you know exactly what's going on, and you'll get good call stacks. There's just a boilerplate command to issue for that. Sudo, because you have to elevate yourself. apt-get, that's the package manager for Ubuntu or other Debian-based distributions. If you're on a different version of Linux, the syntax will be different. And then install, because we're installing something, and we're installing libc6-debug. It's pretty simple once you know it. And that puts the symbols in user lib debug and then a copy of the shared object path. And what I mean by that is if we assume that libc6 is in this big long path, then the symbols for libc6 will be put in user lib debug, that same big long path. So when the debugger is looking it up, it just looks at the path of the shared object that it loaded, appends that to user lib debug, and checks to see, is there anything there? It's a very simple system. And by the way, CGDB and Qt Creator are all based on GDB. They use GDB as the underlying debugging engine. And even from Qt Creator, you can actually go and type GDB commands if you want to do something that Qt Creator won't let you. So when I say that GDB will do something, I really mean and all the other debuggers, because they all derive from it. And I'll talk later about how and why GDB looks in that particular directory. The next set of symbols you're probably going to want are the Steam runtime symbols, because you're probably going to be using the Steam runtime. And there's a few ways of getting this. The simplest one is that when you launch Steam, you can always launch Steam from a command window, prepend steam_runtime equals debug. What that does is it sets the environment variable steam_runtime to the value debug and then launches steam.sh. So it's a common Linux trick of defining an environment variable and launching a program all in one line. That tells Steam to use the debug version of the Steam runtime. So you get unoptimized code that's easier to debug, you get symbols, and it also downloads the source code. So that's going to be the easiest and most powerful way to deal with any problems that you hit in any of the Steam runtime packages. You can also download the entire Steam runtime SDK. You can build it yourself. There's a lot of options there. So next, I need to talk about getting symbols for your own code. But before I do that, I have to talk a little bit about symbol stripping. Now, we're very used to, if you're a Windows developer, with the concept of DLLs versus PDBs. DLL files have your machine code, you ship them to your customers. PDBs have all the debug information, you keep them. And the compiler just automatically creates these two separate files. On Linux, what the compiler natively does is it actually creates one file that has all the machine code and all the symbols. You then need to decide what you want to do, how you want to split them up. So our convention is that our .so files, our shared object files, have the machine code and the minimal number of symbols, basically exports, needed to make things work. And then we have an so.dbg file, which contains everything. It actually has the machine code and it has the debug information. So we ship the .so file, and then we just have to archive the dbg file and know that we've got everything we need. And having one file that provides everything turns out to be kind of convenient. It doesn't actually waste any space because we just archive the one file instead of having to archive two. And there's some tools that work better if you've got the symbols and the machine code in one file. It guarantees that they can always find the symbols. They're right there. Just because my talk didn't have enough pictures, I did some programmer art. So machine code is green, debug info is red, and the dbg file is bigger. That is all. What, do you think I should have animated it? Probably. And the mechanics of this are pretty straightforward. They're actually easier to write shell scripts for than to explain, but I'm going to explain anyway. The compiler and linker build this .so file, and then we copy it to the dbg file, so we've got two copies of the entire large file. You can also add only keep debug, that option, to the obj copy command, and that will strip the machine code from the dbg file. Some people do that, lots of people do that. We don't. You then need to link the two files. You need to put a link in the .so file that points at the dbg file so that when the debugger loads the SO file, it knows where to look for the symbols. GDB won't just go, oh, I think I'll append dbg to the end. No, it won't do that. You have to tell it the name of the file. Not a big deal. Then we strip the symbols from the .so file, the red stuff. We just use -s, which is kind of minimal stripping. -x will strip more stuff, and there's other options. Read the man page for details. Or look at gendebug.sh. We actually ship that in the source 2013 SDK. So you can see exactly how we build our binaries on Linux. So now what do? You got a dbg file, but I would claim you're not really done yet. What do you do with it? If you're developing on your machine, it's not a problem. You just built the binaries so the debug symbols are right there, not a problem. But what if you're running your game from Steam? So you've got a bunch of .so files, you're trying to debug them, how do you get the symbols to show up? You could go root around and figure out what version they were built from and go to the right file share or perforce sync point or whatever. But what are we, savages? This is way too much work. On Windows, it works automatically through the magic of symbol servers. So let's do the same thing on Linux. I am lazy, you should be lazy too. So symbol servers on Linux are one of those dark secrets that a lot of Linux developers don't even know exist. They've been around for about 6 or 7 years, but they're terribly underutilized. They're just a file server and a convention, and they're based on what are called build IDs. These are 40 hex-digit numbers that you can burn into every shared object to uniquely identify them. So the first thing we have to do is tell the debugger, we now want to look for symbols in 2 places. userlib_debug, because we still want those C runtime symbols to show up, and somewhere on our file server. I'll say mount/sims. So now we have to do a GDB command. Sorry, there's still some low-level GDB commands needed. Set debug file directory tells GDB where to look for symbols, and we give it 2 directories separated by a colon. That's it. So now it's going to look in 2 different places. And we can put this command in ~/.gdb init. And the tilde just means this is your home directory, and .gdb init is just a list of commands that GDB and GDB-derived debuggers will run at startup time. And the dot just means that it's a hidden file. So we'll be talking about that file and referencing it a few more times. So once you've told GDB to look for symbols, now you have to put some there. So the first step is easy. Extract the build ID from the .dbg file. So readelf-n is one of the commands that will do that. Like I said, build IDs are 40 characters. I'm doing 20-character build IDs so that they fit on the slides better. The concepts remain exactly the same. Now we need to copy that DBG file somewhere on the file server. Where you copy it is entirely up to you, and I'll give some recommendations later. And now we need to make a link to it, a symbolic link. These are used all the time in Linux. So we have to make a directory. In our symbol server directory, mount/syms, we make a .build-id directory. That'll be a hidden directory, and this is just a standard. This is what GDB is going to look in. And then inside that, we make another directory whose name is the first 2 characters of the build ID lowercase. Why? Because. That's all the depth of explanation I can give you, and that's really a perfectly good reason. Now we make a symbolic link inside that directory we just made, and the name of that symbolic link is the remaining characters in the build ID. So we've got all 40 characters being used now. And that link simply points to the file we put on the server. And the idea basically is we want to spread out the links so they're not all in one directory, because that gets completely crazy, and 256 was exactly the right number of subdirectories to use. Why not? We actually create 2 links. The first one is used to find the machine code file. The second one is used to find the debug information. But as I said, we have everything in one file, so both links point at the same location in our symbol servers. And this is where we put our files. We've got them on the file server. We have a directory per product. It's nice to know how much space you're wasting on the symbol server for each product. Then for each shared object, we have a different directory. Again, completely arbitrary. We didn't have to do that. We just thought it would be nice to know how many copies of the client shared object we have for TF2, and this makes it trivial to find out. Inside that directory, we use the build ID to give each file a unique location, and then we just copy the file, retaining its original name. So this naming convention works perfectly well for us, but this is completely arbitrary. You can do whatever you want. All that matters is that there are 2 links pointing to each file, and those links have to be in the format that GDB is expecting. This is magic. If you're doing Linux development and you're not using these symbol servers, you're making your life more difficult than it needs to be, so now you know how to fix it. So the debuggers are going to automatically retrieve this information. I even put the libc6, the C runtime symbols, on our symbol server. So if one of our developers forgets to install those symbols, they won't even notice, because they'll just show up. That's cool. Profilers on Linux generally don't understand symbol servers, but that's not a problem. If I've got a directory full of shared objects, I can just run a tiny little shell script which grabs all the build IDs for the shared objects, goes off to the symbol server, grabs the DBG files, either copies them beside the shared objects or overwrites the shared objects so that now they have debug information, and then run the profiler. And it has no choice but to use them. I've completely outsmarted their attempts to be ignorant. They're really super handy. I'm sorry, I just get very excited. Okay. Symbols are solved. Source code. Again, if you're building locally and debugging the code you've just built, the source code's going to show up. That's not a problem, so good. But let's say you've got a build machine. And by the way, you should have a build machine. I mean, everybody should have a build machine, but if you're targeting multiple operating systems, it becomes all the more important. When somebody checks something in, it needs to build on Mac and Linux and Windows, so that if they've broken one of the platforms, they find out immediately. We use BuildBot. It's an open source build system. Use what you will, but have a build system. What that means, though, is that the binaries you get back, the binaries you ship to your customers, the source paths are going to be the source paths from the build machine. So /home/buildbot, etc. And the path for the source on my machine is going to be different. Not a huge problem. I just need to make sure I've synced my source code to the correct point in time, so I have the right source code, and then this set substitute path tells GDB, please do this remapping. Works like a charm. But while we're on this topic, how many people use source indexing on Windows to make source code automatically show up? So sad. I'll just do a brief plug for Windows and say source indexing is awesome. You should be using it. And if enough people show interest, I would get it working on Linux as well. But first, you have to use it on Windows. You want to put that substitute path command in .gdb init, of course. For the libc6 source, they don't have a single root for all the source, so you can't do a substitute path. Instead, you just have to add a whole bunch of directories to the list that it will search through. So GDB init ends up looking like this. And also, because I don't like AT&T syntax for disassembly, and that is the default in GDB, you can change the disassembly flavor to Intel, which is basically what Visual Studio uses. So it'll be more familiar. So I'm going to spend a few minutes going over a few tips and tricks, but it's a very open-ended topic, so I'm not going to get to all of them. I'll leave a few minutes for questions. There'll be a few more in the slides that you can look at. And these are basically a grab bag of things that, as a new developer in Linux, you're going, I know that I can use dump bin on Windows to disassemble an object file or a DLL. What do I use on Linux? Well, you use objdump-d and pass it a file, preferably one with symbols, because it's one of those tools that can't handle separated symbols. If you want to get all the symbols dumped out of an object file or a shared object, nm is the tool for that. Valgrind is an awesome and amazing, powerful tool that will find bugs that are impossible to find through any other method. Ryan talked about it this morning. We've used it a lot. It's found some amazing stuff. strace is a tool that lets you attach to a process or launch a process and trace all the system calls and dump the information to a text file. There's a lot you can do with that. Why is this program hung? Is it spinning in a loop? Is it calling fopen, fclose a billion times? Find out. Find out everything you want to know about a process just by looking in the /proc directory. It's this virtual directory that synthesizes information about the processes, and you just explore it to look around and see what's going on. That's just cool. This is kind of the equivalent of the handle command that comes from sysinternals if you want to find out who's got a file open. But this will also tell you things like, what are all the files that a particular process has open? So you can do it both ways, per process or per file. Build IDs are very important because they are the core of symbol servers. So it's very useful to know how to get build IDs out of a core file, a Windows crash dump. It took me forever to find the syntax for that, so I had to share it. If you try and attach to a process on Linux, then you may be told that you don't have the appropriate permissions. And this is a security feature. If one process gets compromised, we don't want it attaching as a debugger to all the other processes and infecting them. And this is called ptrace hardening, and it's annoying when you're trying to debug a process after you've launched it. You can get around it either by disabling ptrace hardening completely with those cryptic commands at the bottom, or by running the debugger as a super user. Yeah. Okay, so I got a bunch of references. Some of them are links to Rich Geldrich's blog and Mike Sardin's blog where they've talked about Qt Creator and other things. My own blog where I talk about symbol servers. And I think we've got maybe 3 minutes or so for questions. So do we have anything?
Yeah, I was wondering, is Valve considering adding features to the Linux side, like Windows has, like Steam API write mini dump to help developers debug on released Linux games?
Right. So is Valve thinking of doing anything to? Well, we're doing a lot of things to make development easier on Linux, specifically around mini dumps. I'm not certain what our current status is. We have a system built around BreakPad, which is a Google project. So that is what Valve is using for our own crash dump reporting, and it's excellent. There are some challenges in expanding that out so that non-Valve developers can transparently use it. Things like, how do we get the symbol files that it requires? How do we share the data out? How do we protect everybody's intellectual property? So it is something that we're interested in. We currently don't have a roadmap for how we're going to get there, but you could certainly contact me offline and we'll get more information.
Have you had a chance to look into the Clang sanitizers yet, or how that affects games?
The Clang sanitizers. I did try using the Clang address sanitizer. Unfortunately, our games don't run very well for some reason when built with Clang. And when I first investigated it, I was a complete Linux newbie and could not figure it out. So I've heard great things about Clang's address sanitizer. We actually build all of our code with Clang just for its amazing warnings, but we don't currently run any of the code with Clang. So that, I would call that one of the future awesome projects that we're going to do, and I would recommend trying it. Yes?
So speaking of Breakpad, I was actually going to ask about that. Have you found or figured out any documentation for Socorro or whatever your version of those QA and reporting and crash reporting tools is? Because Socorro is like the other half of the Breakpad system.
Right. Socorro is, you know, there's another guy at Valve who deals with that. I'm always very happy because I get confused. Yeah, so I'm afraid I can't really answer that in any useful way. We are using Socorro. When you are getting reports from it, we're annoyed that it runs a bit slow, but it is working well. If you want to discuss that more, that'd probably be best as an offline topic, and maybe I can get you in touch with the right person. But yeah, Breakpad is awesome. I will agree with that. And that's it. That's all we have time for questions for right now. But in about 10 minutes, all the people who've been talking about Linux for the last few hours are going to come up. We'll be available to collectively answer questions, and it's also to get together in groups and talk, whichever seems to be most useful. So stick around, and it should be useful. Thank you very much.